In this section, we will introduce model-based feature selection methods. The main idea is to select the features during learning the machine learning models. This feature demonstrates the flow of model-based feature selection. All features are the initial inputs to the feature selection procedure. Basically, the feature subset is iteratively built with respect to the model performance when constructing models. The first method introduced is lasso. The basic idea is to complete regularization and feature selection. It puts a constraint on the sum of the absolute values of the model parameters. The sum has to be less than a predefined value, upper bound. In order to do so, the method applies a shrinking regularization process where it penalizes the coefficients of the regression variables, shrinking some of them to zero. From another perspective, the goal of this process is to improve the model accuracy, where the coefficient for features can be treated as feature weights. This is especially useful when the data has a small number of samples and many features. In other words, it would be effective to analyze high-dimensional low sample size data. For example, cell classification with microarray data in biomedical domain will involve around hundreds of samples with 20 to 50,000 of genes. Lasso would be an effective method to select less than 50 genes for this classification problem. Lasso helps increase the model interpretability by eliminating irrelevant variables that are not related to the target variable, which would reduce overfitting as well. Overfitting refers to a model that models the training data too well. It happens when a model learns the detail and noise in the training data, which negatively impacts the performance of the model on testing data. This means that the noise or random fluctuations in the training data is picked up and learned as concepts by the model. The concepts, however, do not apply to new data and negatively impact the model's ability to generalize. Let me show you an example with linear regression model. Linear model, often called linear regression model, describes the relationship between response y and explanatory variables x. The case of one explanatory variable is called simple linear regression, while the case with two or more explanatory variables is called multiple linear regression. An assumption is the linearity of the model. That is, a linear relationship between the response variable and the explanatory variables. The instructor will show you the details on the explanation of these formulas. An assumption is the linearity of the model. That is, a linear relationship between the response variable and the explanatory variables. It can be implemented with maximum likelihood estimation, MLE. The instructor will show you the details on the explanation of these formulas. Another model-based method is tree-based model. Generally, we can rank the feature importance when constructing the tree of features for different tasks, such as classification. The most common method could be decision tree and random forest. Let me give you a basic example of decision tree. This figure is used to show a decision tree to complete a task, that is, to decide if a job offer should be accepted. The leaf node presents the decision on if the job offer should be accepted. The other nodes show the attributes, features related to this task. Each node will be assigned a weight during training, with methods such as information gain, where the weights can be treated as the importance of the feature. The challenge to build a decision tree is to choose appropriate depth and width for this tree that will affect the performance significantly. We will introduce the details in the Module 14, that is, Introduction to Machine Learning Classification. Thank you.